Good morning. So today we're going to be talking about making the move to Java 17 and kind of covering, some of the reasons why you might want to migrate, as well as talking about, some of the strategies that you can use and tools that you can take to kind of make this process easier. So before we get started, I just kind of do want to ask, just kind of get a feeling of where people are. Just raise your hand. Is there anyone who's, already using maybe Java 17 in production? Anyone? Okay, yeah.
Why are you here? No, just kidding.
What about Java?
No.
What about Java 11? Anyone? Okay. Oh, lots of Java 11. That's really good to see. Java 8. Definitely. Okay, yeah. Yep. I'm not going to ask about earlier. I won't make anyone raise their hand.
Any earlier?
Yeah, is there anyone using earlier than Java 8? There's no judgment here. Okay. Awesome. So just a little bit about who we are. So my name's Alex Motley. I'm a software engineer at IBM, leading the WebSphere migration tools team. So my team kind of focuses on helping a variety of migration scenarios. WebSphere traditional to Liberty, Java SE, as we're going to be talking about today, as well as Java EE, and on-premise to the cloud.
And I'm Cindy. Hi, I'm WebSphere migration tools architect. Been involved with this Java SE migration process for a long time with WebSphere. And my question to you, who remembers when enum became what version did in Java did enum become a keyword? Anybody know? Bingo.
Great job.
So that was the first, Java 1.4 to 5 was our first codifying rules to migrate Java SE versions. And we needed that. That was happening between WebSphere 6 and 6.1. So that's what got us started, enum. All right, making the move. Why would you be interested in migrating to Java 17? There's tons of features that they don't expect you to read this, but the point is there's lots of new features that have come in since Java 8. And these just highlight some of the ones between 11 and 17. Lots of new features are getting added each release. Some are getting taken away. So we'll talk about a little bit of all that. There's lots of new interesting features, in the coding practice. Some of them we'll highlight here just to make your code easier to read, more structured. The introduction of vars for local variables. You can local variables that are initialized get automatically typecast to what they need to be. With this example shows the introduction of also the new methods that make creating collections easier. So we can take 5 lines of code, creating a new var, adding static content to it, and create that in one simple line with some of the new features. Text blocks. We have these blocks of text where we're creating our help text and stuff. So much easier if we could use the triple quote to create these blocks of text to make our code look cleaner and nicer. How many times you've got a null pointer exception and all you see is null? What caused it? What is the root cause? Unless you've printed that full stack trace, but just the ability to see exactly what's causing your null pointer is a big benefit in some of these cases for this new addition to get some helpful text.
This is one of the ones that I'm most excited about, definitely.
Yeah. And records, so many data objects we create just to carry around data, right? To create these records in a line of code to set up all the getters and setters for a data object. What a simplification to take those, create those records in one simple line. And one of the last ones to talk about is the switch statements, switch case assignments, to be able to avoid the bug of not putting your break in there, to assign data to a variable as a result of a switch statement, and the ability to, have multiple labels, multiple constants, comma separated to do your case with. Makes it so much easier, with this arrow operator, lambda operator, to assign, move through a switch and assign it to a variable. It's much simpler constructs here. And then, we've all done this a million times. Had to check if something was an instance and then assign it to the variable with the instance. That gets all simplified by putting your variable name in your instance of line of code. So these are the fun things, and some of the fun things of the language, but as the things change, there's many security-related changes between crypto and TLS. Applet support, that's being removed. Security manager being deprecated, things that been there from the beginning, but the need is not there as much. We've got, the strongly encapsulated JDK internals, hidden classes, and sealed classes. Just to touch on the point that as we are moving through these different Java versions, security is always on the forefront of the minds of creating the best, JDK as can be done, and those latest protections are only in the latest versions of JDK. Security issue when a support of Java goes out of support to continue to use that, the security risk is the highest problem there. All right, and why migrate? If you're providing libraries and tools or jars of infrastructure maybe to your users, you want to be able to enable them to stay on the latest and move up. And we'll talk about this a little bit later, but adopting the latest JDK doesn't mean you always get to use those cool constructs, but it means you have to be aware of the library changes so that you can stay compatible as you move up and as your users move up. Unfortunately, we're one of those tools that we have to still support. We go back to Java 6 and we stay compliant with Java 6. So we can't always use these cool new features, but we will run on Java 17 and we will continue to go forward with that. And of course, at some point, Java 8 and Java 11 will end of life, and we just have to keep moving on. Alex will talk a little bit about some of the strategies of making that happen.
Right, so you might be asking, okay, what version of Java, should I be thinking about, migrating to? You may be thinking, well, this talk is, making the move to Java 17, but Java 19 was actually released last week. And so I imagine most people are probably aware, but I do just kind of want to mention that since Java 8, kind of the Java release process has changed a bit. And so they moved to kind of a system now where they have both long-term support releases or LTS releases, and then shorter-term releases. And so those shorter-term releases are only in support for 6 months, and then immediately when the next version is released, it goes out of support. So in terms of what we recommend for most people is that you really should kind of stick with the LTS releases for production. Most people do not want to do a Java migration every 6 months, and there's not really much time to make that move if there was some change that kind of did affect you. Now that being said, we wouldn't recommend that you just wait and do nothing until Java 17 or 21 comes out and decide, okay, let me look at it now. We really do recommend that you set up continuous testing, you set up a CD pipeline, and you're kind of always running and checking with each new release, even the non-LTS ones, and so you're kind of aware of maybe what changes are going to affect your application, what's changed, and so you can kind of iteratively do that, and then when the next LTS release comes, you're kind of ready to move to that one. So at this point, we'd recommend that Java 17 is kind of what you think about migrating to, and then next fall, so September of next year, Java 21 will come out, and that'll be the next LTS release.
And this is exactly what our Liberty team does. If you come by our booth and saw the Space Rover and we talked about Open Liberty, they're continually updating to support that latest release to enable their users, if they want to move to that Java, to do so, but also so there's no big bang as well. So they're just constantly moving forward.
Yes. Okay, and now we're going to kind of get into the core of the presentation and talking about what are the top issues that people need to kind of address when they're doing a migration from mainly Java 8 or 11 to 17, but even if you're in older Java versions, this will be relevant as well. And so there's kind of 4 main focus areas that we're going to talk about today. Obviously we can't cover everything, but kind of the 4 main categories we find that affect people are missing libraries, removed APIs, modularity and strong encapsulation, as well as out-of-date dependencies. So, first looking at the removed libraries. So this one is really kind of mainly something that is, if you've already moved to Java 11, you've kind of already dealt with this. And so this is really kind of more affecting people who are still on Java 8 and earlier. So there were a number of Java EE libraries that were actually a part of Java SE that were removed in Java 11. And so if you haven't moved to Java 11 yet, when you do so, these are going to affect you. So these are things like Corba, JTA, and the one that we find that kind of at least affected us the most was JAX-B. And so for this one, it's not necessarily a really complicated issue to resolve. There are a couple caveats that we'll get to later. But generally, if you're using an application server, that will often provide it for you. You may just need to enable it. And then if you're not, you'll just need to package those on your own in your application. There were a couple other libraries in Java 11 that were removed as well. So Java Web Start was removed, and there's an open source project, Open Web Start, that can be used if you were using Java Web Start. Java FX is another one that I know had a lot of usage that was removed in Java 11. And so if you were using Java FX, you can use OpenJFX as a replacement. And then in Java 17, the Nashorn and JavaScript engine was removed. That was added in Java 8, so I don't know that it necessarily had a ton of users, but if it is something that you were using, it's publicly available on GitHub, and it will work with Java 17, so you can supply that in your application. And then one other library, and this is a little different. So for those of you who use Java EE, you might be aware that that was donated from Oracle to the Eclipse Foundation and open sourced. And so as a part of that process, it's now called Jakarta EE. And so if you are migrating to Java 17, or newer versions of Java, you may want to consider moving up to the newer Jakarta EE versions of those libraries. And we'll talk a little bit about that during the demo and how there may be some instances where you need to do that.
All right, removed APIs. So these are the ones that we've got multiple streams. We don't have them all here, but we just kind of listed some of the removed packages and classes that we certainly scan for in our tools. You can also plug in your Java you're intended to go through and let your IDE do its work and tell you what's been removed and what's not. But look at there are quite a few things that have been removed, and you can go back to, say, most of these have been deprecated for a while, so you can go back to the old Java docs and look at some of the what is the new ways of doing this particular function. But yeah, and Alex is going to show in his demo some of these transformations that we've done, but that can be done for some of these things that have been removed. I mean, we've been warning people for a long time through our tools, not to use some packages and things of that nature because they're considered internals, and finally, a lot of these things are getting removed or no longer accessible. So remove classes, remove package, some remove methods. They've taken particular methods out of different classes, and these are the things that will hit you as if you're, want to move completely up to Java 17, or if you, just want to tolerate it. It's always worth checking it out. Something might surprise you that's in your code that has been removed. They've definitely gotten more assertive on taking things out that were either unsafe, dangerous, from a security perspective, one of the ones that are problematic. Finalizers are one of those that have been taken out. Many of the finalizer methods and run on finalizer on exit, that's been removed, and because of problems with performance or the code just not getting called, it just wasn't reliable, and things of that nature. Again, more packages, and some were 11, some were 17, but a lot of things are getting removed, and in particular methods and so forth. And we're seeing more and more this little star of APIs now throw unsupported operation exceptions. So this is one of those where pointing to your IDE is not going to tell you necessarily there's an issue, but when you go to runtime, then you might get some exceptions that some operation isn't supported anymore. And so that's something, where you're testing your bank of tests, that's always important, and to help you run through and understand any problems you might have with a new version of Java. All right.
Okay. So now we're going to talk about modularity and strong encapsulation. So some of you may be aware, starting after Java 8, the Java Platform Module System, or JPMS, was introduced. And so this was a way to kind of try and introduce some modularity to the Java language. So it allowed for code to be broken down into modules which contain packages, and then those applications would declare their dependency on those modules. And so one of the core reasons kind of why this was introduced, or the main motivation, was to kind of try and encapsulate some of the JDK internals, that we weren't perhaps supposed to be using, but that were widely used, and to kind of try and lock some of that down. And as a result, this can be very disruptive for Java SE application migrations. And so this is one where it's kind of something that they, over time, have made changes because they didn't want to, immediately break everyone all at once. So if you are just kind of moving to Java 11, they by default in Java 11, actually, the behavior didn't change. So they introduced the illegal access flag, and the default was permit, which essentially meant that in Java 11, the behavior was the same. And so if you've heard of the kill switch, that's what that refers to, as the illegal access flag. However, in Java 11, they've actually gone through, and initially they changed the default so that by default the illegal access was not permitted, and then they removed it entirely. So if you're moving to Java 11, you no longer have the option of using the kill switch to get around the modularity changes that have gone in. And so, obviously kind of the ideal scenario would be that you stop using the illegal access, and there are some tools you can use to do that, either JDEPs, or you can set the illegal access flag to warn or debug just to see where in your application this is used, and we'll show that in a bit. And then the other option would be, if there is something that you can't remove, you really need to continue to use, you can add that module using the add opens jar launcher or jar manifest attribute to be able to still access those in your application.
That just reminds me that the add opens, the experience they had with EJB.
Yes.
For remote EJB, that was a scenario where add opens came in useful as they were serializing back remote EJB calls and things of that sort. So an area to be aware is if you are doing Java EE and using remote EJB.
Yes, and reflection as well, for that matter.
True.
So any time you're accessing kind of other modules, it is something to be aware of if you're seeing kind of behavior changes. And then finally, we'll talk about out-of-date dependencies. And so this is one where there's kind of probably a lot in your application. You're probably using several libraries. ASM is one that we get with our tools, but other things like Mockito, Spring especially. We often see people using kind of very old versions of Spring, and so those are one, unsupported, but often also will not work with newer versions of Java or Java EE, as well as Spring Boot. And so definitely time to kind of, move up, see, what the latest versions of those libraries are and move to those. As well, things like your build tools, IDE, application servers, if you're using those and whatever, kind of those you're using, you'll want to make sure that you're using the latest of those, or at least one that will support Java 17. And so my advice here is really, security obviously is becoming more and more, kind of a focus and important. And so we really, should be staying up to date anyway and not kind of falling behind with dependencies. So definitely I think this is kind of a good time to, take an inventory, see what versions of all of these that you're using, update, start using the latest versions. And then, anything you can do to, automate this or use tools there to kind of help you stay up to date then in the future will help not just with, migrating, but also with security and making sure you're staying up to date.
All right, deprecations. I alluded to this earlier, but with the later versions of Java, they've really started flagging things more, not just deprecated, but deprecated for removal. Kind of implies and has been the action that means they really are serious about not only deprecating, removing the functionality, they want to get it out and take it out. Yeah, little buzz there. And so even in our tools, we've gotten more serious. In the past, we haven't really flagged deprecations and just let the IDEs tell you about those. But we've gotten more serious in our tools and encourage you to look at those more closely. If you realize you're using things that are deprecated for removal, there's a good chance that it will come out, and you'll need to make adjustments for those. So anyway, there have been we've seen more and more things that long time deprecated, they've come out.
Right, and that's where, thread destroy and stop, I think we're deprecated, Java 2, 3? I mean, it's been deprecated forever, right? And, in the past, it's just kind of like, okay, don't use it, but it's still there. And, they are actually now saying, okay, we are actually going to remove these. So, definitely do, if you do see something deprecated for removal, you actually need to pay attention. You can't just, ignore it anymore.
That's right. The thread stop throwable is gone. Thread stop is still deprecated. Watch out. Who knows when it'll be gone. And tools, what we're finding ourselves, of course, we're embracing containerization, but that's really a good way to stay up to date if you're starting to use containers, to easily change your Java versions, update, run, and test your applications, and stay with the latest fix packs as you're building and testing applications. Containers make that quite easy. But there's also a set of tools, command line tools, that some of these that we built, some of these we recommend. And one, I alluded to, we started with this in a tool from 1.4 of a SE 1.4 to 5. That was actually in an Eclipse source-based tool. That tool still exists. We still have it out there to do evaluation of your Java source code. The tools that we use most frequently now is our binary scanner, and that's a command line tool, or you can use it from a Maven build that will scan your binary, your ear, your war, your jar, and do analysis on that, where you can see what changes you would hit when moving, say, I think it goes back to that one. The binary scanner goes back to Java 5, but you set your source Java SE and your target Java SE, and it gives you this nice report to tell you what you've hit, what we've seen in the applications. It'll also tell you if we found stuff that we recommend you run in JDEPs on, and that's the second tool here. JDEPs comes with the JDK itself, and it's also a command line tool, and you always want to use JDEPs with your target. If you're moving to Java 17, you want to use JDEPs with Java 17, not what you're coming from, because it changes and it builds on the what's changing from the current Java level. Then tools to automate your dependency updates. These dependencies, you know, they get old, and unfortunately we don't always look at our applications to figure out what can come out, what should come out, what's duplicated in our application, what's snuck in we either don't use or don't need, just simply by not marking something as provided versus as a needed dependency. So things like Dependabot can help check versions. And then the last one is it's Java EE, the Eclipse Transformer. You know, we talked about the Jakarta libraries that are coming in for Jakarta 9, Jakarta 10, follow-ons from Java EE. There is an open source Eclipse Transformer tool that will convert your application, and it's cool. It can work on source code or it can work on your application binary. Us being in the application server space, we use that a lot just to build a little test application. We need a Jakarta. You did this multiple times. You need a Jakarta application versus a Java EE application, and that Eclipse Transformer tool can be used to convert Java EE to Jakarta EE. All right.
Okay.
Oops, sorry, I went too far.
No problem. So now we want to kind of actually show off some of these tools that we've been talking about. So rather just kind of, you know, tell you about them, we want to show you, you know, how you can use them. So I'm going to go ahead here and pull up an application that I have. It's a simple application, but we'll still kind of walk through it here. That runs on Java 8, and then we're going to go ahead and use the tools to migrate that to Java 17. So like I said, it's a simple application. It has two classes. One of them is just an object that is used to store data that will then use JAXB to convert into XML, and then I can use that for, you know, whatever purpose I need it to. And that's just kind of representing address, so, you know, the street, city, state, zip code, etc. And then in the kind of main application class here, you can see I go and I create an address, specify I live in Rochester, Minnesota, so put that there. And then write it to XML using JAXB here. As you can see, if you've used JAXB before, you know, just the standard way of doing so. And then I also, you know, want to encode and decode my address itself. Maybe I don't want people to know my exact street address, and so I'm going to, you know, encode that. And I do that using this base64 encoder and decoder. So let's go ahead and actually run this application. I'm using Maven here, and so we will go ahead and run it. So I'm just going to do a Maven clean install to build the application, and it should be quick since it's a small application, and then I'm going to go ahead and run it. It's just a jar, so we'll go target, and as we can see, it you know, converted the address, which I created, into XML, and then encoded and decoded the address. So why don't we go ahead and change to Java 17. So I have a little just script here that'll, you know, change the Java home as well as the path. And so just to show, we can see I am now using Java 17 here. And you know, let's just try and run it again. Let's see what happens, right? You know, that's not necessarily, you know, sometimes that's a good first step, right? Like, just see what happens. So we'll go ahead and run that. And no surprise, given that it's a demo here, right? We do have some issues. So it looks like it's related to JAXB, which, you know, isn't a surprise based on what we've talked about today. So in my POM here for this application, and all of this demo, by the way, is in GitHub, and we'll have the link, you know, at the end, so you can access it and pull it down and run through this yourself. In the POM, I actually have the binary scanner that Cindy had mentioned, and so I'm using the Maven exec plugin to configure it. And so here I am just kind of pointing to the location in Maven where the jar is built. I'm saying that I want to analyze the application for Java SC, since we're doing that kind of migration. I was using IBM Java 8, so that's what I have specified here, but you know, it could be Oracle Java 7 or whatever you're using. And my target where I want to move is obviously Java 17. And then just put some config as well, just to say that I don't want it to open in a browser automatically. and the output of where I want the report produced. So we'll go back here to Maven, and I'm just going to run Maven exec Java, and that will execute the report. And I did miss in the POM here, just these are the Maven coordinates specifying the most recent version of our binary scanner. So that has already gone and run the report and told me where it was loaded. So we'll go ahead and open that report up. And as you can see here, this has flagged that there are 5 rules that I'll need to address in my application, and 8 total results. So some of those occur in multiple places. And we, within this, kind of have 3 different levels of severity, if you will. So critical are ones that you're going to need to make a change. It's going to affect your application, and it's something that you're really going to need to take care of. Warnings are more rules that there's differences. They might affect your application. The reality is static code analysis, looking at the bytecode, there are some limitations about what can actually be detected. And then informational, we kind of talk about more as things you should read through kind of before you do your testing, just so that you're aware of changes. And if you start to see some oddities, you can kind of connect, oh, I read that, and go back and look further there. So we'll start and go through this. And this first rule we have here is telling me that we shouldn't use APIs from the Sun packages, which is one of the ones that Cindy had talked about. And so this will give you help. So we can read here that it said that SunMISC base64 encoder and decoder were removed. If you remember, that's what I was using for the decoding. So that's gone now. And instead, it tells me that I should use this Java util base64 class as a replacement. So we'll go ahead and do that. And another thing you can do, obviously, as a tool is use your IDE. So I'm going to go ahead here. I'm using Eclipse, but any IDE you can do this in. And I'm going to say I want my compiler at the compliance of Java 17. And then I will go ahead and change my JRE to Java 17 as well. And so this is also going to help point me in the right direction of what in my application I need to change. So I'm going to go ahead and remove these SunMISC base64 encoder and decoder, and it said I should use Java util base64. So we have that, and now we need to go and modify where we were using the old base64 encoder and decoder. So we're going to change this to be base64.encoder. And we are going to change this to just be encoder. And so, base64.getEncoder. And this is, again, where your IDE will kind of help point you in that right direction. And then the encode method has actually changed so that now it is actually encode to string. And so this is kind of just the strategy you'll need to work through as you're kind of trying to figure out exactly what has changed. As Cindy said, often the Java doc will point you in the right direction, but you can also just use kind of your IDE to also figure out kind of what the new syntax is. And then the base64 decoder is going to be the same. So we'll do base64.getDecoder, and then it has actually changed to just be decode. Okay, so we made these changes, and now what did we? Okay, we changed. And so now one thing that has changed is actually these no longer throw, I need to remove the new. One thing that has changed actually now is that they no longer throw an IO exception, so we're just gonna go ahead and delete that. And make it so that it looks nice again. And I deleted the wrong base64.getDecoder. Okay, there we go. And I renamed, I might have deleted too much. The pain of a live demo, right? Okay, so we will do base64.getDecoder.decode, and then we'll remove the try. Okay, so next we'll go back, and we believe we fixed this, so we'll go ahead and look at the next issue in the report. And here we'll see that it's recommending that I run JDEP. So it's detected that somewhere in my application, I'm using some internals, and so they're recommending that I run JDEPs with the JDK internals flag to kind of see what JDK internals I'm using that I'll need to resolve. So we'll go ahead and use the command they recommend here. And so as Cindy said, you always want to make sure you're using the JDEPs version that you are migrating to. So this is updated with every Java release with changes, and so I want to make sure that I'm using the version that comes with Java 17 because I'm moving to Java 17. So as we can see here, I am, and I can make that a little bigger. So we're going to go ahead and use the JDK internals option, and we're just going to point it at my source code. And or at my application. And this is what the output of JDEPs looks like. So it is a little verbose, but you can kind of figure out how you read through it. And so in this case, it's actually telling me something that I already knew. So it's telling me that the base64 encoder and decoder were removed. They were previously JDK internals, and that I should use the Java util base64. So we've already done that. In this case, it didn't give us more information, but it's a good tool to run to kind of see these types of changes, and this is the type of information that it will give you. Okay, so then moving down, now we just have some informational rules to go to. So the first one here is telling me that I was using JAXB. And with all of these, it will also tell me where in the application I was using them. So this one's informational because it's an easy change. All you really need to do, right, is add the library to your application. So we'll go ahead and do that in a moment. But also did kind of want to point out just some of the other informational rules quickly. So this first one is one of those deprecations that Cindy talked about where we're starting to flag these now because they are something that you do need to be aware of sooner than later. So in this case, in my application, I was actually using a constructor for, in this case, an integer, as you can go ahead and see here. And so those have all been deprecated and will be removed in the future. And so right now I'm not going to worry about it, but it's definitely something where moving forward, I am going to want to be aware of that I'm going to need to no longer use that constructor. And then finally, we have what we call kind of the general information rule. And this is one where, if any of you have ever opened up the migration guide or release notes, there's a lot in them. And so it can be hard to kind of read through all of that, figure out, what do I actually need to pay attention to, what's going to affect me, and what are changes that I don't really need to worry about. And so, obviously we try and in our tools add as much as possible, but there are some limits of static code analysis. And so we try and distill and just list, some of the changes that, aren't necessarily being scanned for, but that you should be aware of that might affect you and that you should just, in your doing your testing, look at and see, okay, this is something I want to think about. This is something that, I think I use this, maybe I should be aware. And so that's what we have here for general information. So let's go ahead now and resolve the JAXB in our application. So I already have here in my POM actually the dependencies for the latest version of both the API and implementation, the reference implementation for JAXB. So we'll go ahead and save this. And if we go back and look at our application, we see, well, wait a minute, this is, I still have errors here. What's the problem? And so I kind of alluded to this before, but in this case, I'm using the latest version of JAXB because I want to stay up to date. I want to use this opportunity to use the latest versions of dependencies. Now, if you're familiar with the latest version of Jakarta EE, they've actually changed the package names. So what used to be JavaX XML bind is now Jakarta XML bind. And obviously for an application like this, it would be trivial for me to go and just update manually those imports, but I want to show how you can use the Eclipse transformer to do that. So I've already downloaded the Eclipse transformer. It's an open source tool, and so we can see I have that here in the transformer. And so again, it's just a jar that I'm going to run. So we'll do java -jar transformer / Eclipse. Oops. And then in this case, I'm going to put it at my source code. I don't want it to modify the binary itself. I want my source code to be modified. So I'm just going to go ahead and point to my source directory. And it's going to quickly run, and it knows exactly what needs to change. So the reality is there are still some JavaX packages that are part of Java SE. So you can't just go in Eclipse or your IDE and just say replace all JavaX to Jakarta. That's going to be a problem. There are some that are still JavaX. And so the transformer will know which ones need to be changed, which ones don't. So it's definitely a tool I recommend that you use to go through this change. So that actually went and produced a output source folder. And in this folder, it has the modifications. And so we'll just go ahead just to easily see the difference. We'll look at a comparison. And here you can see, in this case, like I said, it's a relatively simple scenario, but it updated the JavaX imports to be Jakarta. And so we'll go ahead and copy those over. And then same with the application class. We will go ahead and compare and copy those over. Okay, and now we can see in our application, we no longer have any errors, and so why don't we go ahead and now try running it on Java 17. So we will rebuild the application first, since we've made a lot of modifications. And then once it's done building, we'll go ahead and run it. Target slash. And as we can see here, now it's running exactly as it was on Java 8, but on Java 17. And we have the XML that's been produced, as well as the encoding and decoding of the address. And so, obviously this was kind of a simple application, but this is kind of the strategy that we recommend that you take, even with larger applications, and look through, use some of these tools, try it out, run your tests, and be iterative. Take it one step at a time. It can be easy to get overwhelmed, right, with all these changes, but take it one at a time, and you can work through them relatively easy. So with that,
excellent.
We'll go back. Okay.
All right. So kind of what are the steps here? Of course, you can do these in whatever order. We talk about, use your tools to evaluate, use your JDEPs. Load up our tool. We'd love for you to download our tool. It's free to use, easily downloadable. We'll have the link at the end. Or you can just, like most programmers, just give it a try, right? You want to just plug in your new Java, see what happens. That's kind of what we like to do. But whichever way you approach, there is lots of information to be had from the tools, and I'd love for you to try them. And try that Java 17, you get the exception, you kind of start digging in, see what's going on, do your debug, do your modifications, and keep going through those steps of iteration to move yourself forward. Can't stress those dependencies enough. You got to look at those dependencies, see what continued to work on the level of Java you want to move to, see what are certified for your levels of Java, and move on up. And then run all your tests, test, most important thing we do, right? Those automated tests, and then be happy and celebrate.
Celebrate,
You've
yep.
got your running application in the end.
You've done it.
That's right. We've got lots of links here. If you want to take a snapshot of that, of our tools you can download, of Alex's GitHub repo, and just things that we find useful. I don't know how the conference is sharing slides. We'll probably put these out on SlideShare somewhere as well. And then is there... Okay, and also today, most of our IBM sessions have gone, but Emily Jang has a session this afternoon at 1:15, looking at microservices, and I think that's,
it'll be right back here in the same room.
Yeah, and questions. What do we have for questions? Yeah. Oh yes, absolutely we have. We've scanned huge enterprise applications. And it's quite fast. The binary scanning, if you're talking about our tools, quite fast. I mean, it does take longer, 100 meg applications. Yep, we've done them. We've seen it all. We've seen multiple copies of Spring Boot in applications. We've seen dependencies. Right. Dependencies not used. We've got a really cool report as part of that scanner that's called our inventory report. and that'll work on ears and wars. So that's an EE type tool. Ears and wars. If you have a jar, you really want to do it, throw it in a war, and you can get the inventory of it. And what that does is looks at everything within your application. It looks at gives you a graph of the application, what dependencies, what we think are used and not used. If we can't find a code call to it, if you're using reflection or something, you might trip us up on that. But it gives you a great inventory of everything in your report, and it's a really good learning tool, especially if you're starting an application you're not totally familiar with. It'll tell you all your Java EE servlets, beans, everything that's in your application. And anyway, yeah. Give us a big application. We'll take it on.
Yeah.
You don't have to. I mean, there are a lot of things that we hit at 11, which were those removals. You might go in steps, but you don't have to. Our rules, as far as our tool, we consider it cumulative. So if we're scanning an application from 8 to 17, we're going to apply those Java 11 rules. But, I mean, have you had more success or less than?
I mean, it kind of depends in terms of your strategy. Sometimes it is easier to kind of break it into pieces, and so maybe you want to see, okay, we'll make the Java 17 adjustments, then we'll go and do Java 11 adjustments, and then the Java 17. Or maybe sometimes it's easier just to see everything at once and then, work through them step by step. It's kind of personal preference. The one reason I think a lot of people haven't considered moving to Java 11, at least just thus far, is for a lot of vendors, and obviously this is different for each vendor, but for a lot of vendors, actually Java 8 is supported longer than Java 11, so a lot of people are like, okay, well, why would I move to Java 11, right? What I have is fine.
Right.
But Java 17, now we are kind of getting to the point where, it is supported for longer, so it is kind of the time to start looking into that and making the move.
Right.
Yeah.
Okay.
Any other questions?
Yeah.
Yeah.
The add open in the manifest file, is it possible to set that in like a library and have the application use that, or is that only for jars that are getting actions executed?
That's a great question. I'm not sure.
Yeah, I'm not, so like where the library, you're saying, kind of needs those other access to those other modules.
If the library needs access to the modules, how do I want
Right.
the library to have those open clauses?
Right, and that's where, I think you may be able to modify the jar to specify those, add opens in the manifest, or I guess even perhaps run them from the command line. But
Right.
What?
Writing library.
Oh, yeah, if you're writing the library, then you can put those in the manifest of the jar.
Okay.
Right, yeah, because it'll be a part of the jar itself that they pull in.
Other questions? Okay, for those of you, I'll ask my question. For those of you who have moved on up, what were your biggest stumbling points? What was the hardest thing of moving to 17 or 11? Dependencies. Yeah, and it's just they're not moving fast enough and not ready? Okay. Okay. You had old dependencies.
I had to upgrade all the dependencies first.
Okay.
That and some of the modular stuff.
Okay.
Yeah.
And were your applications Java EE applications, or were they just Java, just straight Java? Okay. Cool.
Okay.
Anybody else? All
If
right.
not, we'll be around the stage for a little bit, or you can find us in the IBM booth or around in general, so feel free to come up and ask if you have any other questions. So thanks for coming today.
Thanks for coming.
Yes.
Yeah. Thank you.